drag, or air resistance, is basically an object is moving through a fluid, and that could be moving through air or moving through water. The abbreviation for it is capital D in this textbook, but we pretty much ignore it in almost all of the problems. So how about we say can be ignored unless specifically referenced. Like friction, air resistance is always going to kind of work in a direction to prevent the motion. So maybe I had a baseball and it was moving through the air this way, so I'd have a velocity that way. So the ball would feel a drag force working against the motion. Drag force. And we're going to just right now say amount varies. But how about I go ahead and tell you that it increases with speed, right? There's more air resistance on your car if you're going down a highway than if you're going slower on a city street. Thrust force is basically going to be kind of like rocket propulsion. And so, if you imagine a rocket, it would burn fuel and exhaust that gas, basically explode the gas out of its engines. So as the rocket explodes the gas backwards, it pushes the gas backwards, the rocket feels a force forward. So we'll call that the thrust force. F thrust. And as I just wrote there, the abbreviation is a capital F. And your book just says TH. You can do that, or you can actually just write it out. The amount varies, but it's going to be in a direction opposite of the exhaust.
I suggest you skim section 4.3. It gives you a way to think through a problem and imagine all the forces acting on an object. I don't really follow their technique of drawing a picture and drawing a closed curve around it, but if you find that you're stuck or having a hard time identifying the forces on an object, you can come back here to section 3. What I do find helpful is this table here, and maybe just having that table somewhere handy. And then for a certain problem, you can just kind of go through the table and ask yourself, is there weight? Is there a spring force? Is there tension? And then just go down the list, and that'll also help you identify which forces are happening. I'm going to suggest you guys skim through section 4.4. It just is going to be the idea that if the object has a net force acting on it, like imagine a block being pulled with a rubber band, it will accelerate. But if you double the amount of net force, or you double the amount of unbalanced force acting on it, it will double its acceleration.